Okay, hi grade 10s. Hi Sam, nice to see you again. Hi Tanika, I hope I said your name correctly. This must be your first lesson with us. I don't remember your name from the last time. Anyway, if it is, welcome. We're very pleased to have you here with us. So like always, there's a do now on the screen for you to have a look at until the others arrive and we get underway. So just have a look at that question and see if you can work out 4.11 or 4.12. And then we'll go through it with the others as soon as we get underway. Hopefully you've got your calculator and a book to write in and a pen. And that's what you need. Where's everybody, Tula? It's only Sam and Tanika that are here with us. It's 5 o'clock. I don't know where everybody else is. Ah, there we go. There's Nolwazi. Hi, Nolwazi. Nice to have you with us again. Hello, Lumela. I don't recognize your name. I don't know if this is your first time as well. If it is, welcome to Watobe. Hope you'll find these sessions here with us helpful to you. Who else have we got? Karabo, welcome back, Karabo. Nice to see you again. Okay, I'm just going to wait a couple more minutes and see who joins us. There's a do now on the screen. So let's see if you can answer 4.11 and 4.12 yourselves. I will go through it with you. But I remember the last time when we were doing geometry, we said we needed practice with more sorts of questions like this. So that's why I thought I would start here. Oh, good. Some more familiar names. Hi, Marisa. Hi, Sihle. Welcome back. Nice to see you guys again. Glad you joined us. Hi, Megan. Okay, so as I've been saying, sorry, I sound a bit like a stuck record. Please try and see if you can answer the do now that's on the screen at the moment. We're just going to wait for everybody to arrive and then we'll get underway. Hopefully you'll be able to answer at least the first question. I will go through all of this with you. Oh, some more familiar names. Hi, Maya. Hi, Harry. Hi, Sinanhlanhla. Nice to have you back with us. Hi, Sihle. And David. Hey, David. Nice to have you back with us. Lesejo, welcome, Lesejo. Thanks, Sihle. You always send such nice messages. Thank you, Sihle. Lesejo, I think you might also be new. If you are, welcome to Watobe. These grade 10s that are on here, we've been together for a little while now, so we all kind of know one another pretty well. So welcome to our little grade 10 family. I hope you'll be happy here with us. We are going to be doing this course on exam preparation, and then that will be followed by some Q&A sessions towards the end of the month. So yeah, just gearing you up and getting you ready for exams. Okay, so normally what happens, those of you that are new, is we normally start the lesson with a do now. And I will do another Kahoot quiz with you guys because I think you really enjoyed the last one that we did. So we'll definitely do that again. But I remember the last time, I don't know if it was Anam or Sam, I don't know if it was you, but somebody had said, please, can we practice more questions where we were calculating angles. Hello, Zayan. Nice to have you back with us again. And I felt that this would probably be a good place to start. Was it you, Sam? I thought so. Okay, yeah. Anyway, so I went and I dug out. This is also an exam question, Sam. So the sort of thing that you could potentially be asked. So I thought that this was a good place for us to start, and then we can go back and we can have a look at how we were going to prove that a quadrilateral is a parallelogram. Okay, because that's not something that we managed to discuss, unfortunately, when we were doing geometry. So there's just a few things that I still want to cover with you guys. Okay, so if we have a look at the information that's on the screen at the moment, they've told us that in the diagram, angle E is 2x. They've told us that angle C1 is 75. They've told us angle C2, so this one over here is 2x minus 15. And they've told us that angle B2 is 135 degrees. Okay. What didn't they tell you? If you look at the picture very carefully, what aren't they saying? Does anybody know what I'm trying to get at? If you look at the first question, okay, it says to us, there we go, Harry, good. Okay, so if you have a look at what Harry said, David, look at what Harry said. They don't tell us that the lines are parallel. Can you see that, Nolwazi? Look at the picture, okay? And in the information, nowhere have they said to us, EF is parallel to GH. If EF was parallel to GH, then answering the first question, determining the value of X, would be really, really easy. But they didn't tell us that. So now we can't use corresponding angles. We can't use co-interior angles. We can't use alternate angles because we don't know if EF is parallel to GH. So what are we going to do to work out the value of x? We're not allowed to use parallel lines. What do you think? I can see two things, but I just want to know, what do you guys think? What can you see that we could use? No one got any ideas? You're also shy tonight. Hey, nobody's saying anything. Angles on a straight line. Okay, Nolwazi, where angles on a straight line? What are you suggesting? Are you maybe talking about, are you talking about that?
Yes, ma'am.
Okay. You know what, Nolwazi? I almost fell into the same trap as you. I also thought about angles on a straight line, because what I wanted to do is I wanted to say that this angle over here is also 2x. Can I do that though? Am I right?
No.
No, because I don't know that these lines are parallel. So I'm making an assumption. They probably are parallel, but I don't know that they are. So I can't do that. I also thought about that one. Right. So I'll put you out of your misery, guys, and I'll give you another little hint. Okay. So they've named this one over here angle B2, and they've named this one over here angle B1. Okay. Angle B1 and angle B2 are also adjacent angles on a straight line, aren't they, Nolwazi? So theoretically, we could work out how big B1 is. The other thing that would be true is that this angle over here and this angle here, B1, what sort of angles are they? The two ones that I've done in pink, what would we call them?
Something about opposite.
Correct, vertically opposite?
Yes, ma'am. I don't know, ma'am, but then I know it's opposite something, ma'am.
Quite right, Sam. Thank you. So B1 and this angle over here, which I suppose we'll have to call EBC or CBE, they're vertically opposite, and vertically opposite angles are equal. So if vertically opposite angles are equal, we could then use the angles of a triangle to work out the size of x. Okay, because we've got 2x inside here. Does that make sense to everybody? Questions?
Sorry, ma'am. Please.
Do you want me to repeat what I'm saying, Sam?
Yes, please.
Okay, so Sam, because they did not tell us that EF is parallel to GH. Okay, yeah, I know this is a difficult question, isn't it? It's no problem. I'm going to explain it to you again. Because they didn't tell us that EF is parallel to GH, we are not allowed to use the angles that are created by parallel lines, because we don't know if our lines are parallel. So we cannot use corresponding angles. We cannot use co-interior angles. Now, it would be so easy if we could, because we could say that that was 2x, like Nolwazi suggested, and then we could use adjacent angles on a straight line. But we can't do that because we don't know if EF is parallel to GH. So we can't assume that this angle here at C is going to be 2x. I can't do it that way. The other thing that I can't do is this, right? I cannot say 135 plus 2x minus 15 adds up to 180, again, because I don't know that the lines are parallel. I could do that if they were parallel, then those would be co-interior angles. So I've got to think of another way to be able to work out x, but I can't use corresponding alternate or co-interior angles. So what I see is that I know how big angle B2 is. Angle B2 plus angle B1 adds up to 180 degrees, right? Because they are adjacent angles on a straight line. So if I write here, so I'm going to do 411 over here, angle B1 plus 135 adds up to 180 degrees, okay, because they are adjacent angles on a straight line. So how big is B1 then? David, can you tell me how big is B1?
45 degrees.
Okay, thanks, Harry. Perfect. It's 45 degrees. Okay, so that's it. Yes, good. So this angle over here is 45 degrees. It's vertically opposite this angle over here. So this one is also 45 degrees. So I want to call this angle, I'm going to call it EBC. EBC is also 45 degrees because it is a vertically opposite angle. Okay, and now what I want to do, grade 10s, is I want to work inside the triangle. Okay, so I'm going to work inside. Sorry, my lines are always so skewed. I'm going to work inside this triangle that I'm highlighting for you in green. Okay, the angles of a triangle add up to 180 degrees. So I'm going to say 45, that's this one here, plus 2x, plus 75, adds up to 180, angle sum and triangle. Okay, so that means that 2x is going to be, someone's going to have to work this out for us. What is 180? That's okay, Namusa, welcome. Nice to have you with us. What's 180 minus 75 minus 45? What does that leave us with?
$60, ma'am.
Does it leave us with 60, Marisa? I agree with you. It does leave us with 60. Good. Okay, so that leaves us with 60. And now what have we got to do to both sides? Divide by 2. Okay, exactly. So x will be equal to 30 degrees in this case. Okay. Does that make a little bit more sense? How do you guys feel now? Do you want to give me some emojis?
Ma'am, I have a question.
Maya, go for it.
If, for example, a question says that the shape we are dealing with is what's this thing called? A parallelogram.
Mm-hmm.
For us to assume that there are not corresponding, parallel lines and equal angles and everything, and all the properties of a parallelogram.
Absolutely, Maya. So if they tell you that a quadrilateral is a parallelogram, then it assumes all the properties of a parallelogram. So the diagonals will bisect one another, the opposite angles will be equal, the opposite sides will be equal, the opposite sides will be parallel. What have I left off? Yeah, all of those things, all of those properties, you can then assume that those are true. Okay, so Karabo, no problem, anytime, Maya. Karabo, you say, how did we get 60? Okay, so what we did, Karabo, is we moved, we want 2x on its own, so that's why we're going to take the 45 and the 75 over to the other side and change the sign. Okay, so it would have been 180 minus 75 minus 45. Does that make sense, Karabo? Okay, all right, so you understand where the 60 comes from now. All right, one thing that David said to me is he said, yeah, it's quite long, and you're right, this is quite long. The only other way that I could think of to do this question, David, was to do it using exterior angle of a triangle. So let me show you that as well as an alternative, okay? So let's just get rid of all that writing. And let's just look at it from this point of view as well. Okay, so one of the other bits and pieces of information that your teachers would have taught you about triangles is that if you have a triangle, and I mean, we obviously do in this case, I'm so irritated with myself for drawing skew lines. Sorry, grade 10s. Okay, so if you take one of the sides of the triangle and you extend it, can you see how we've taken side CB and we've extended it to A? We get what is known as an exterior angle. It's an angle on the outside of the triangle. And the exterior angle of a triangle is equal to the sum of the two opposite interior angles. Does that sound familiar? It's called exterior angle of triangle. We could do it that way as well. So in other words, what I'm saying, David, is this. I'm saying that our alternative is this. So we state that angle ABE is 135 degrees because of vertically opposite angles. Right? Then we do this. We say that 2x plus 75 is equal to 135. Exterior angle of triangle. So the exterior angle of the triangle is equal to the sum of the two opposite interior angles. So in other words, if I add 2x and 75 together, I will get the exterior angle. And now have a look. So now I'm going to say 2x is equal to 135 minus 75 is going to leave me with what? Again, it leaves me with? You guys getting 60? Divide both sides by 2, and x would be equal to 30. So you could do it that way as well. That's a little bit shorter. What do you think of that, grade 10s? Does that make sense as well? That's what you wanted. Okay. Oh, well, there you go. Yeah, it's always nice to to go the most direct route. Okay. All right. So either or. Is everybody happy? Is this making sense? Can you give me some thumbs ups or thumbs downs? How are you feeling at this point? Is that okay? Thanks, Marisa. Thanks, Nolwazi. Thanks, Karaba. Okay. Thanks, Tanika. Please don't be afraid to ask questions, okay? It's no problem. That's why we're here. Nobody's going to judge you. Ask away. We're all learning together. Okay, so those are our two alternatives as far as I can see for calculating x. I had a good look at this, and I can't really think of another way. No, actually, no. I think that's all I would do. Okay, all right, good stuff. Then they say to us in 412, determine if EF is parallel to GH. Motivate your answer. So now they're saying to us, are these lines parallel to one another? So what we need to do is we need to verify whether in fact what we've calculated, whether it holds true. So there are a number of different ways in which we can do this, okay? First of all, what we could do is we could calculate, if you have a look here, we already know how big angle B1 is, don't we? From here, from what we did in the beginning, we worked out that B1 has to be 45 because of adjacent angles on a straight line, okay? What we could do is we could then work out what the value of x is over here if we used corresponding angles. Okay, so in other words, this is not the only alternative we've got. This is just one of the alternatives. All right, so let's do it like this. We know the corresponding angles are equal, right? So let's work out what so in other words, sorry, let me just set it out like this. It's angle C2. Angle C2 is equal to 2 times 30 minus 15. So 2 times 30 is going to leave us with 60. And 60 take away 15 is going to leave us with 45. But we know that angle B1 is equal to 45. But we know that angle, whoopsie, it was B1, not A1. Angle B1. But we know that angle B1 is equal to 45 degrees, right? So we could either say proved in 411, or if we want to say adjacent angles on a straight line, that's okay. So adjacent angles on a straight line. That means that C2 equals B1. C2 equals B1. And therefore, EF is parallel to GH because corresponding angles are equal. Okay, what do you think of that? Does that make sense to you? Do you have questions? I can show you another way we can answer this question as well.
Ma'am, could we have proved that they're parallel if we used co-interior angles?
We could do. What we would need to do is we would need to, again, work out what 2x minus 15 is, all right? And then so in other words, if we do it like this, okay, like in the same way, we want to work out C2. So let me just choose a different color, okay? So I'm going to do it in purple. So over here, again, we're going to work out how big is angle C2. So it's going to be 2 times 30 minus 15, which we know is 45 degrees, okay? If we take 45 degrees and we add 135 degrees, we get 180, don't we? So what that means for us is that angle C2 plus, that's fine, Akila, have a look at what I'm doing. I'm doing it by co-interior angles as well. Plus angle B2 adds up to 180. So that means that EF must be parallel to GH because co-interior angles are supplementary. Whoopsie. Okay, so that's another way that we could do that question. All right, so we've proved. Absolutely. Absolutely. But you see, with this, Marisa, it's more the way in which it is set out because they're asking us a question. Are these lines parallel? Okay, so the lines will be parallel if corresponding angles are equal. The lines will be parallel if co-interior angles are supplementary. The lines will be parallel if alternate angles are equal. That's the other option that we could do. All right, so the other thing that we could do is we could work out in terms of x how big this angle is. That's another way we could answer this question. Is that making a little bit more sense to everybody? Akila, someone on their iPhone, I'm not sure who that is. another way, please, ma'am, but I also understand this one. David says he's fine. How are the rest of you feeling? Is it making sense? The two different options. I can also show you the alternate angles are equal with this particular question. Are you happy though? Cool, Maya. Thanks. Okay. You sure? All right, Marisa. Thank you. Okay, so we're working backwards to prove that lines are parallel, okay, or determine whether lines are parallel. We're not starting out by assuming that they are. Okay, so now let's get underway with what we really wanted to do this lesson. Okay, I'm glad, Lesejo, that's good. You must just ask questions if there's anything you don't understand, okay? I don't mind how many questions you ask, all right? So, guys, one of the things that they will definitely get you to do in grade 10 in an exam, in a paper 2 exam, is to prove that a quadrilateral is a parallelogram. Okay, now this is studying. I'm sure you've realized now that you're in grade 10 that maths it's still about practice, but it's also about learning. Okay, so you've got to study the rules and the methods. Otherwise, you don't know how to play the game. Okay, so it's like I teach boys normally, and I always say to them, okay, so I'm standing on a rugby field and I'm running with a ball and I decide to throw the ball forward. And then the ref blows the whistle. And I'm like, well, what's the problem? What's the problem? And he says to me, oh, but you don't know the rules. You're not allowed to do that. And I'm like, I can't play the game, can I? So it's exactly the same in maths. If you want to play the game, you've got to know what the rules are. So you have to study the theory and then you have to go and put it into practice. So part of studying your theory is learning stuff like this. How many different ways are there for us to prove that a quad is a parallelogram? Well, there are only 4 here, but there are actually 5. So these are your options. Okay, so either you prove that there are 2 pairs of opposite sides that are equal to one another. Okay, so if you can prove that AB equals DC and AD equals BC, then it means that ABCD will be a parallelogram. Okay, and our reason for that is this one here, 2 pairs of opposite sides are equal. Or you could prove that there are 2 pairs of opposite angles that are equal to one another. So in other words, if you can prove that A equals C and that B equals D, then you would also be able to prove that ABCD is a parallelogram. And our reason in this case would be 2 pairs of opposite angles that are equal. Okay, this is a very common one. All right, so what we can do is we can also prove that there is 1 pair of opposite sides that are equal and parallel, but it has to be the same pair. Okay, so if AB is parallel to DC, then you need to prove that AB equals DC. Okay, in order to prove that it's a parallelogram. Okay, our reason there is 1 pair of opposite sides equal and parallel. And the 4th way of being able to prove that a quad is a palm is if you can prove that the diagonals bisect each other. So in other words, if you can prove that AK equals KC and DK equals KB, then you've proved that ABCD is a parallelogram, okay? And there, the diagonals of a parallelogram bisect. That would be your reason. The only other way that you could do it is if you were given a quad, you could prove that there were 2 pairs of opposite sides that were parallel. Okay, and then that would also prove that a quad is a parallelogram. So now I'm going to go and grab this question that I want to do, this one here, and I'm going to put it next to these reasons. Whoopsie. Let's just sorry, I'm just making a mess of things, but I'm fixing it. Okay, so now look at this question, okay, and we're going to keep the how to prove a quad is a parallelogram on the page at the same time, okay? So let's read this. ABCD is a parallelogram. G and F are the midpoints of AD and BC respectively. Prove that DGBF is a parallelogram. Okay, so they've told us that ABCD is a parallelogram. What does that mean? So this is what we were talking about it assuming all the properties of a parallelogram. What can I say about AB and DC apart from the fact that they're parallel? They are also
equal to one another.
exactly. Brilliant. Okay, so they are also equal in length to one another. So now the next question. All right, AD and BC are also parallel to one another, but what else does that mean? They're also
Equal.
They're also equal. Okay, absolutely. So let's use a different color. All right, so 2 little sticks through here and 2 little sticks through there. Okay, so if this side AD is equal to this side BC, and they tell us that G is the midpoint of AD and F is the midpoint of BC, what are they really trying to tell us? What does that actually mean for us? Anybody know? What does it mean? Any idea? So this is not part of the answer just yet. It's just part of helping you understand. G is half the length of AD, I think. Yes, Namusa, you are on the right track. Good. So if AD is equal to BC, which it is, and G is the midpoint, and G is the midpoint of AD, then it means, just as Namusa was saying, it means that AG equals GD. Does that make sense? So if G is the midway point, then it means AG equals GD. Does that make sense to everybody? And it would be exactly the same on the other side as well. So it means that BF is also equal to FC. Is everybody happy with that?
Yes, ma'am.
Okay, so if we know that AD is equal to BC, and we know that AG equals GD, and we know that BF equals FC, what could we say about the 4 constituent parts? They all have to be equal to one another. So it means that AG has to be equal to GD, which has to be equal to BF, which has to be equal to FC. Now, what's really important to us here is this. Okay, is it making sense, Marisa? Now look here, this is what's really important to us. GD being equal to BF. That's really what's important. Why? Because if it is, right, then this side over here is parallel and equal to that side over there, which means that DGBF is a parallelogram because look at our reasons. We have got one pair of opposite sides equal and parallel. Does that make sense? How does that feel, guys? If it feels rubbish, then you say rubbish. I really don't mind. I'm happy to explain it again. Understood. Okay, cool. Nice. If you don't understand, you don't have to say you understand. If you don't understand, you're welcome to tell me. We're going to set it all out nicely now. I'm going to show you what to do. I'm just explaining the sort of background stuff. Okay, so when they ask us to prove that a quadrilateral is a parallelogram, I'm going to rub this off because I'm going to do it again, okay? I'm going to set it out in the correct way. This was just us discussing the problem before we actually got into how we would formally set out what we're trying to prove. Okay, we've got to try and match up our problem, the one I'm shaking, to one of these three different situations over here. All right, now I know nothing, there are no diagonals. So that means I'm not even going to try and prove the diagonals bisect one another because there are no diagonals in this problem. I also do not know anything about the opposite angles. I don't know anything about angle A and, well, I do. I know that angle A is equal to angle C, but angle A and angle C are not inside the parallelogram or inside the quad that I'm trying to prove as a palm. So that's useless to me as well. All right, so I'm going to throw this reason out of the window. All right, so it's got to be one of these two. Either I need to be able to prove that this side here, GB, is parallel to DF, right? Because then I'll have two pairs of opposite sides parallel. Or the only other thing I can do is prove that GD equals BF because I already know that they're parallel. Okay, so I already have one piece of information. I have one pair of opposite sides that are parallel. So if I can prove that they're equal, then I can prove it's a palm using this particular reason over here. And that's what I went ahead and did. Okay, so now setting it out formally, it's an argument. When you are doing a proof, you are presenting an argument, a statements with reasons in order to prove something is true. Okay, so we've got to set it out in the correct way. All right, so what we will do is this. Okay, first we want to state that AD equals BC. Okay, and that is because they are the opposite sides of a palm. Okay, then we have been given G is midpoint of AD and F is midpoint of BC, given. Therefore, AG equals GD and BF equals FC. Actually, in fact, what we could do here, sorry. So AD equals BC because they are the opposite sides of a parallelogram and the opposite sides of a parallelogram are equal. So if G is the midpoint of AD and F is the midpoint of BC, because we've been given that, it means that AG equals GD equals BF equals FC. Okay, but we have been told that GD is parallel to FB because we were given that ABCD is a parallelogram. So now we can conclude, therefore, okay, GD is parallel to FB and GD is equal to FB. Therefore, DGBF is a parallelogram. Our reason, one pair, opposite sides, equal and parallel. What do you think? How do you feel, grade 10s? Cool, David, I'm glad. Oh, good, Sam. Nice, that makes me feel good. Everybody else, what are you thinking? Tatuka, Namusa, Nosisa, Sihle, you so quiet. Nowazi, Maya, Lesejo, what do you think? Does it make sense? Cool, thanks, Namusa. Thank you. Okay. Oh, good. Yes, I also hope you remember this when you write your exams. Shame. Okay, thanks, Sihle. Thanks for all the feedback. Okay, that does make me feel a little bit better. All right, so now let's go and have a look at the next problem. Okay. It's this one over here. So now sometimes what they can do is they can get you to prove congruency before you prove that something is a parallelogram. It's okay, Sihle. I understand that shame. I know that you always try. Don't worry. That's fine, Osisi. You watch it again on YouTube. Not a problem. All right. So now, do you remember that time where Miss G came in and she gave you guys that lesson on congruency? So this is where it ties together, right? They've told us, let me just make this a little bit bigger because I think it's a bit hard to see. They've told us that KLMN is a quadrilateral with only KL parallel to JM. So we do not know if it's a parallelogram or not. P is the midpoint of JL. So that means that JP equals PL. The first thing that they want us to do is they want us to prove triangle KLP is congruent to triangle MJP. So if you recall, when you prove congruency, okay, you have to set it out formally. Okay, so in 2.1, here we will write, in triangle KLP and triangle MJP, we have to think of three things that we are going to say. Now, remember our conditions for congruency. Do you remember what they are? The four conditions. How can we prove two triangles are congruent? What's the first one? SSS, do you remember that? Side, side,
Yes,
side.
ma'am.
Okay, so we've got side, side, side.
Angle.
Angle, Nolwazi proves similarity.
It's SAS.
Side, angle, side.
That's it, SAS.
Side, angle, side.
Side, angle, side. And it's got to be the included angle. Okay, the angle between the two sides. What else?
SAS.
Angle,
Side, angle.
That's true. You're all correct. You're all right. Okay, angle, side, angle, or sometimes people say side, angle, angle, or sometimes people say angle, angle, side. They all mean the same thing. Okay, and then the last one, right angle, hypotenuse, side. But there are no right angles in this question, so we're not going to worry about that. We also don't know anything about all three sides. We only know something about one side. So we're going to throw that in the rubbish bin as well. Okay, we can't use that. If we have parallel lines, it means that we can have what sort of angles, grade 10s? we could have alternate angles. So what I'm trying to show you is that this angle over here will be equal to that one over there. Similarly, this angle over here at L will be equal to this one at J. So we've got a side and we've got two angles. Can you see that? So it's going to be this one. Does that make sense to everybody? All right, so first things first, okay? JP is equal to PL, given. Number 2, angle LKP. LKP is equal to angle PMJ. Because they are alternate angles. Whoopsie, alternate angles. And that is because KL is parallel to JM. Okay, Marisa, I am going to go through this again, okay? Then in number 3, I can prove that angle KLP is equal to PJM. Again, there are alternate angles because KL is parallel to JM. So therefore, Marisa, these two triangles are congruent to one another. Triangle KLP. Okay, so now I've got to make sure. Oh, sorry, that's the similarity symbol, not the congruency symbol. Is congruent, and now it's got to match. Yes, you could. You could also work with this angle over here and that angle over there. But you can't say angle, angle, angle. Okay, so we've got to use side angle, angle, side angle, or side angle, angle in this case. But yes, that's also an option. You could have done that too. All right, so angle K goes with angle M, angle L goes with angle J, and angle P goes with angle P. Okay, so they are congruent to one another. Reason, side angle, angle, side angle, angle. Karabo, it doesn't matter if either way is fine. If you do it like that or you do it like that, no one's going to mind. Okay, so it's just two sort of straightish lines next to each other like that. Okay. Marisa, does that make sense now that I've finished, or have I lost you?
Yes, ma'am, I'm beginning to understand just a little.
Is it a little bit better? So in other words, what we've done is that we've had a look at the information that we've been given, and we've decided on how we're going to proceed with one of these 4 things. We have to make a choice. We don't know anything about side KP and side PM. We also don't know anything about side KL and side JM. So we can't use side, 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 because the 2 of the 3 sides we know nothing about. So that's why that got crossed off. As far as right angle hypotenuse side is concerned, KLP and PJM are not right angled. So that's why this one got crossed off. Side angle side, it has to be the included angle. All right. So as far as included angles are concerned, if we use this angle over here, then we need this side and we need that side. Now, we don't know anything about KP and PM, so we can't use side angle side. Similarly, if we're now talking about angle M over here, side, angle, side, we don't know anything about side JM and side MP. We don't know that KL is equal to JM. We don't know that KP is equal to PM. So it doesn't matter which one of the interior angles we work with. We can't do side angle side because we don't know enough about the side. So that's why it has to be angle side angle or side angle angle in this case. It's the only one of the four that's going to work. So we've got side JP equals PL. We can't have anything else here. And then I decided to use the two alternate angles. But I could have, if I wanted to, I could have used one alternate angle, and then I could have used vertically opposite angles as my third one over here. All right. Or I could have used, so either the purple alternate angles together with the vertically opposite, or I could have used the red alternate angles together with the purple vertically opposite, or I could have used the two alternate angles. It really doesn't matter. Okay, so all of those combinations would be correct in this case. So now that we have proved that triangle KLP is congruent to triangle MJP, what does that mean? What does it mean? What does it mean about KP and PM? It means that KP and PM have to be equal to one another. Exactly, okay, because of congruency. All right. It also means that side JM has to be equal to side KL because of congruency. Exactly. It means that KP and PM are equal. Yes, Numusa, it does. And it also means that JM and KL are equal to one another. So now, if we look at our last question, they want us to prove that JKLM is a parallelogram. So again, let's go back up here and go and have a look, all right, at how we would do that. Let's just move this down, okay? Prove the diagonals bisect each other. Have we done that? Have we been able to do that? Have we been able to prove that the diagonals bisect each other in this case? Yes, we have, because we've been able to prove that KP equals PM, and we've been given that JP equals PL. So we could use this if we wanted to, okay? Or prove that there's one pair of opposite sides equal and parallel to one another. We could do that as well. All right, because KL is parallel to JM, and through congruency, we've proved that KL equals JM. Yes. Yes, quite right, Namusa. So this would also, can you see now in this particular question, there's a few options. There's actually not just one way to do it. There are a few ways that we could do it. And if you did it this way, or if you did it this way, they would both actually be correct. All right, let's go further up and have a look. Proving opposite angles are equal to one another. We don't know anything about the angles. And then proving that the opposite sides are equal to one another. Well, we don't know anything about side KJ, and we don't know anything about side LM. So it's going to be either one of these two that will do it. Sorry, Nalwazi, ma'am, can I ask, will we be asked to solve something like this in the Cartesian plane using coordinates? Yes, Nalwazi, but that's when you are doing analytical geometry. Okay, so this is Euclidean geometry that we're doing here. But in analytical geometry, yes, they will take these and then they put them onto the Cartesian plane, and then you've got to work out coordinates and the equation of a line and the length of lines. You've got to use distance formula, gradient, midpoint, all that kind of stuff. Okay, all right, so just to do something different, I'm going to go with the diagonals bisecting one another. All right, so in 222, we're going to do this. We're going to say, okay. So KP equals PM, okay? And that is because proved by triangle KLP. Sorry, I'm so used to with the matrix doing similarity. Triangle KLP congruent to triangle MJP. And we've been given JP equals P, and what was up here in this corner? PL, oh, there we go. PL, and that was given. Okay, so therefore, JKLM is a parallelogram. Okay, and this is because there are the diagonals of a parallelogram bisect each other. Okay, so that's another way that we would be able to do this. Now, I just want to ask if there are any questions, because I'm going to have to go in like a minute's time because I've got to go and do a matric lesson after this. How's everybody feeling? Is this making sense? Is this something that you want to talk about a little bit more? How do you feel, everybody? Yes, we can continue to talk about this in the next session. I've got more stuff that I can show you. Some of the other ways to prove that a quad is a parallelogram. Just more practice. Okay, Sam, no problem. A little bit of practice will do. Absolutely, Marisa. It certainly will. Okay, you're still getting confused over the bisecting thing. Okay, well, we'll talk about the word bisect a little bit more. I'm glad, Lesejo. We'll talk a little bit more about the word bisect the next time that I see you. Okay, and we'll sort of discuss it in terms of angles and in terms of sides. Okay, because either lines can be bisected or angles can be bisected. Okay, still a bit confused, but getting there. Okay, no problem. Akila, this is not easy. Okay, this is difficult. So, you know, don't feel bad. Sure, no problem, Tanika. All right, yeah, you need an opportunity to practice this as well. All right, so what I'm going to do now is I'm going to hand you back to Tula. And I'm going to go, and then I will see you guys again on Thursday. Okay, anyway, I hope you have a good week at school and that everything goes well. And thank you so much for being part of this lesson and for being such an amazing group of grade 10s. Okay, I'm very proud of all of you. Well done on your efforts. Okay, bye, Tula. Thank you. Can I leave you?
Bye, Miss Franklin. See you on Thursday.
Thank you. See you Thursday.
Bye.
Bye.
Hello, everyone. I don't have a lot of stuff to present today, so we're still going to finalize the sort of the schedule for like the revision that we're doing, the exam prep. So I'm going to let you go now, and then when I see you again on Thursday, I'll have like the whole thing mapped out in terms of what we're going to be doing. I think we'll be doing algebra, geometry, on all of that. The next few weeks are going to be like really intense, but I think they're going to be really valuable in terms of you guys preparing for your final exams and all that. So make sure that you attend, and if you happen to miss a lesson because life happens sometimes, just go back and watch the lessons. Remember, we record all of these sessions and then we store them on Watobe live lessons on the website. So just go over there and then just so you make sure that you're getting value for being part of Watobe. You know, we want you guys to do well. End of the year, we want you to feel like the time that you've put into this has been worth it. So yeah, I'll see you all on Thursday, and I'll have the proper course mapped out for what we're going to do, and then we're still thinking about that. So yeah, I'll see everyone on Thursday. Enjoy the rest of your evening. You do not have homework for today, but just, you know, study as usual, and then I'll see you guys on Thursday. Enjoy the rest of your evening. Bye. If you have any question, just pop it on the chat and then I'll answer it quickly for you. Any comment, any question, but otherwise I think we're done. You guys can enjoy the rest of your evening. Bye everyone. Karabo is asking about the YouTube videos. You missed a lesson, tried to catch up with the video, but there was a 2-week video only. That's which lesson did you miss, Karabo? That's, I mean, all the lessons, we literally record all the lessons. So everything should be there. It would be interesting. Do you know which date exactly that you missed? And then I'll try to find out for you what the issue might have been, and then I'll send you a message. So yeah, did anyone else have trouble finding that lesson? Any lesson? So just let me know the date that you missed last week. That is strange. They should all be there. Literally every single one of them should be there. We did not have any issue or any problem. So everything should be there. I'll look for last week. I'll make sure last week for Tuesday and Thursday are all there. And then I'll give you an update as soon as I know what's going on. Either send you a message or I'll come back with an update on Thursday. So yeah. You're welcome. Bye everyone.